doing good? Woo! That's what I like to hear. Okay. I like to keep things, bubbly and upbeat. All right, so as Bobby said, my name is April Elliott, and today we are going to be talking about from La Nina to Enso Neutral, what it could mean for Portland snow. So obviously we want to know, is it going to snow in Portland? We have snow lovers, not so much snow lovers in here. That's great, I get it. As a kid, I was like, heck yeah, we want a lot of snow. As an adult, I'm like, I don't really like commuting in a lot of snow. Always a good time. All right, so just a little overview of my presentation today. We're going to look over my forecast from last year. Spoiler alert, was not very happy with it. But, we live and we learn. And we're going to go on ahead and then move forward into this year. Going to briefly go over Enso SOI cycle for this year. We've already talked about it, so no need to sweat on that too much. Talk about some broader climate drivers and their impacts on winter weather. And then we're going to look at past winters with similar Enso SOI phases as well as broader climate drivers. And then we're going to look at our forecast, which is what we all want to know about. All right, so I took the idea from Tanis, gave myself grades, we like grades, from my last year's forecast, A being awesome, F being like, why the heck did I put that in there? So last year I literally copied and pasted stuff from my slides and put it into this fun little table, starting with a cold snap. Definitely did not have a cold snap. Gave myself an F on that. I would have failed that. We did see some overnight lows in the 20s and 30s in late January as well as mid-February, but nothing that's worth really giving myself credit on that. An ice event, I said that we'd have some sort of an ice event. We did see some freezing rain, about 1/10 of an inch at PDX on February 13th. So yes, an ice event did happen, and I did say that mid-February was in the cards, so gave myself a B on that. High wind event. I should have put the February one on here as well, but I did not. We did see some sort of high wind events. Nothing, I didn't think we'd see anything notable. There was nothing really notable. Gave myself a C on that. And then snowstorm, totally blew it on that one. No snowstorm, sorry. I was excited, y'all were excited. We didn't get a snowstorm. And then my snow totals were definitely on the high end. We got some snow, but definitely did not get as much as I was looking at. So, what the heck happened last year? Like, why was it so far off? So, looking at just kind of last year's ONI forecast in comparison to what actually happened, we did see, as everyone has said, a very teetering weak La Nina. And our SOI index was actually positive as well, so everything was in sync on that front. We kind of expected that. So I don't think that was a major issue, though I think that there was something to be said about that. It just wasn't something that I thought was like the reason why the forecast was so far off. And then looking at our Pacific Decadal Oscillation, which is something I love to look at when putting these forecasts together. Expected to remain negative, we remained negative. So that likely was not the issue as well. So where did I go wrong? Felt like Snoopy here. I was pretty bummed about that. Guys remember this? We talked a lot about this. Yeah. I was kind of looking at the solar cycles, and we were seeing a solar maximum through much of the winter months. And so I know in my previous forecasts I really don't talk a lot about solar cycles. But I do think there was something to be said about the maximum that we observed last year. And we were still kind of on like a high end of the solar maximum. So these units I have here in this table are in SFU, so solar flux units. So things were pretty high last year, and so I think that actually played a massive role in what we observed, and we'll talk a bit more about that as we go through this year's forecast. So as my grandma would always say, you learn more from your mistakes than you do from your successes. So I have learned my lesson, and I'm hoping this year I'm going to nail it. So are we going to see a La Nina or Enso Neutral? Brief overview of that table. We've already gone through that. It looks like we're going to be transitioning out of a weak La Nina into an Enso Neutral phase. So the first part of winter, kind of a very weak La Nina. Latter part of the winter, looking into an Enso Neutral phase. Looking at our SOI index, or the Southern Oscillation Index, it looks like we are going to stay on the positive to average range, which is an excellent signal for a La Nina to Enso Neutral sort of phase. And there's that guide right there if you guys are unfamiliar with that. Basically, the SOI measures the difference in atmospheric pressure between Tahiti and Darwin, Australia. So it's just the atmospheric response to the current ENSO phase that we are in. So if these are not in sync, then that's where you'll start to see kind of an odd variation between, oh, it should be a La Nina like winter, but we're seeing more El Nino sort of conditions, or vice versa. So let's look at some broader climate drivers that impact winter weather here in the Pacific Northwest. So as I mentioned before, the Pacific Decadal Oscillation, basically PDO is a long-term climate pattern involving shifts in sea surface temperatures in the North Pacific Ocean. So a positive phase means warmer sea surface temperatures near the US West Coast and cooler sea surface temperatures in the Central Pacific. On the contrary, a cool phase means cooler sea surface temperatures near the US West Coast and warmer sea surface temperatures in the Central Pacific. So typically when we see a negative PDO, that will weaken and shift the jet stream northward, leading to cooler and drier winters in the Pacific Northwest. A positive PDO will strengthen and shift the jet stream southward, bringing wetter and stormier winters to the Pacific Northwest. So as of September, PDO was at negative 2.38, which means we're in a negative or cool phase, and that's expected to last through the winter, the upcoming winter. Now, I mentioned solar cycles. Again, this is kind of was interesting to me for me to look at. It was just a new thing to kind of consider in my winter weather forecast. And so after looking at various different ways that we measure solar cycles, I felt that the 10.7 centimeter solar flux, otherwise known as F10.7, was probably going to be the most relevant to impacts on our seasonal climate shifts. Basically, it's a measure of solar radio emissions at a wavelength of 10.7 centimeters or 2800 megahertz, and it serves as a proxy for overall solar activity. So this includes sunspots, UV, EUV emissions, and magnetic energy. So the higher the solar flux is, the more solar radiation that affects the thermosphere and ionosphere. And then on the other side of it all, a low solar flux means less solar radiation. And for those of you that don't know where that is located, that is that top layer of the atmosphere right there. So why the heck does this even matter? So stratospheric and tropospheric coupling is going to be the most important aspect of this. So this basically alters the stratospheric polar vortex and planetary wave propagation. So a high solar flux will result in a strong stratospheric polar vortex, whereas a lower solar flux will result in a weak polar vortex. Other impacts that it has is it also affects the Hadley cell strength, the Aleutian low, as well as the North Pacific high, but that's more of a summertime thing for us. And then blocking frequency over the North Pacific. One thing to keep in mind, it does not directly cause ENSO or PDO phase shifts. So in case that was a question, I wanted to make sure that was there in my slide. All right, so if we see a high flux, we have a stronger stratospheric polar vortex, as I had mentioned. So typically in the Pacific Northwest, this results in mild and wetter conditions and gives us less snow. Of course, with a weaker polar vortex, we tend to see more of these cold air intrusions. And a lot of times people kind of mix these things up because the media will be like, oh, polar vortex. No offense to anyone in the media, but that's commonly thrown, more in the Midwest, but that's commonly thrown out there. But think about it like a top, right? If the polar vortex is strong, the polar jet stream is also strong, and it's stable, and just kind of hangs out there in the poles, doesn't really dip down to the lower latitudes. But as it weakens, it gets more wobbly like a top. And so you'll get these little troughs that will form in the polar jet stream, because the polar jet stream will also weaken as well. And so that's how you get cold air to intrude into the lower latitudes. So that's kind of the best way to think about it. I've always felt like it was like a top, so I hope that kind of helps it make sense. So looking ahead to this winter, it looks like we're going to be looking at more of on the upper end of the solar average, or we're going to be looking at moderate activity. So we're coming down from that peak that we observed. But with that being said, it doesn't mean that we're completely out of the woods, as Kyle and Jim have mentioned earlier. So we could still see things kind of get a little bouncy there. So I think this is going to have a bit of an impact on the proxy years that I at least looked at, and the amount of snow that we're going to see here in the Pacific Northwest. So historical winter patterns at PDX with comparable ENSO phases as well as broader climate influences. So in order to pick out my proxy years this year, I used the following credentials in comparison to what average dynamic models and average statistical models were putting out there. Basically transition us out of a weak La Nina and into an ENSO neutral phase. And this was a list of years that I found. And then there's just the forecast for this year. So all of these years started off as a weak La Nina, ended right around an ENSO neutral phase. So I was like, great, this is a good data set to start working with. I also wanted to make sure that there was no weird out of sync SOI phases that had occurred, and everything that I had picked out appeared to be relatively in sync with positive SOI. We do see that 64 and 65 as well as 96 and 97 started to show much more of an El Nino phase around April. I only throw April in there just so that we can see, hey, is there going to be possibly some late season snow? I know we saw that back in 22 and 23, so we want to make sure that we keep that in mind. All right, so years of similar ENSO phases and the total snow totals at PDX. So on average, when we just look at weak La Ninas into ENSO neutral phases, not considering anything else, we on average see 6.34 inches, and this is looking at data back to 1950. The years where we saw the most was 50 and 51, as well as 64 and 65, with 13 and 11 inches respectively. We also saw years with little to no snow. 96 and 97, we had none. And 2000 and 2001, we had a tenth of an inch. So nothing impressive on those fronts. Now we want to look at negative PDO as well, and here's just all the years with negative PDO since 1950. On average, we see about 6.01 inches. We've had seasons with quite a bit of snow, over 2 feet. And then we've had seasons with no snow. Actually, out of the 35 seasons, 6 of those seasons had 0 inches of snow. So kind of combining these together, I wound up getting 5 out of those 9 that had a negative PDO, as well as going from a weak La Nina into an ENSO neutral phase. And these actually produced quite a bit of snow, 8.68 inches, which is awesome. We had a couple years with over 10 inches, actually a few years over 10 inches, and then last year was fun with 3 inches, so that's always a good time. All right, and so like I had said before, I also considered solar cycles. I tried to pick some close proxy years, and I looked at every year since 1950. I just completely disregarded my other proxy years. And I only found 2 years that had a monthly mean SFU range between 145 and 185. And then I was like, well, I should probably broaden this because that's definitely not a big enough data pool to pull from. And that gave me a healthier data set. But looking at annual snow values at PDX for all of the proxy years I got, we got about 9.6 inches. But when we look at the ones that have very close monthly mean SFU ranges in comparison to what's being projected for this year, we only saw about 0.85 inches as our average, which I thought was quite interesting. So, kind of pulling out all my proxy years together and considering our solar cycle, 2000 and 2001 was the one that probably was the closest. And for snow lovers, you're probably going to be sad to hear there's only, again, a tenth of an inch. So, that was, I thought, an interesting, a thing I found in my analysis. So these are from September 18th. This is the Climate Prediction Center's seasonal outlook. Like Tanya said, these are not by verbatim, but they give you kind of an idea of what at least they're seeing on their end. So this is November, December, January. We're looking at December, January, February, and January, February, March, and then February, March, and April. So we kind of start out, it looks like, I know with the latest one, we're trending a little bit on the cooler side, but things are going to start to kind of really cool off as we transition to more of an ENSO neutral phase later in the season. So, what everyone's waiting for. What is going to happen this winter? 1 inch to 2 feet of snow. There's actually some legitimacy to that. All right, so this year, as far as other things other than snow, I do think we'll see some sort of a hydrological event, localized or widespread flooding. I think if anything like that's going to happen, it would be early season or late season, and I'm really leaning towards the earlier end of things. And I'm really thinking it's probably just going to be a localized event, but it'll be something we'll probably talk about at least for a couple weeks until something else pops up. But yeah, I think we'll see something happen, some sort of interesting atmospheric river or yeah, high sort of rain event. A high wind event, I do think that's also a possibility, November through January. I don't expect any notable windstorms, but at least some sort of wind advisory will be issued for Portland. That's not super unusual, but looking at past winters with similar ENSO cycles as well as broader climate drivers, high wind events to some degree have seemed to happen, so I wanted to mention that. A cold air event, not a cold snap. I did not say cold snap, I said cold air event. Sometime January and February. I think this is what's going to probably lead to any sort of snow event. But it'll probably be just some shallow or some cold air coming in from the gorge. So I don't forecast any Arctic blasts or anything like that happening. And then an icing event late December through mid-February. Probably going to be minor, nothing historic or out of this world. But I mean, to say that we're not going to see freezing rain, I mean, most years had some sort of icing event that fell within my proxy years. All right, so snow forecast. Putting everything together, I think we're going to see just shy of 4 inches this year. I did give a range of 0 inches to 6 inches. I wouldn't be surprised if we actually see a lot of close events, but PDX maybe gets nothing. But it's also possible that we see a snow event or two where PDX gets a few inches and it adds up to closer to the 6-inch range. I do think that the bulk of PDX snow is likely to occur between January and February. I wouldn't be surprised if we saw some trace amounts late December, but I don't really think we're going to see much of a December snowstorm or snow event for that matter.